These slides, we're going to talk about ionic bonds and their dot structures. So just a little background information. There are two types of bonds. The first one, ionic bonds, we're going to talk about that first. That's what these slides have to deal with. But there's also this thing called covalent bonds. And our next slides will address covalent bonds. So ionic bonds, here's the definition. They arise when one element completely transfers an electron to another element, forming an ionic compound. So you're going to be predicting the ionic bonds. And so in order to do so, you need to know what valence electrons are. And then I'm going to give you one more definition, and then we're going to work through a couple of these. Valence electrons are electrons in the highest occupied energy level of an atom. And so if you think about chemistry, chemistry is just simply changes of electron configuration, transfers of electrons, sharing of electrons. That's what chemistry is. And so why valence electrons are so important is because they're the outermost electrons, and those are the ones interacting with other atoms and other elements. And you're getting the transfers of electrons and sharing of electrons. So how you know how many valence electrons a particular atom has, it's based upon what type of element it is. So if you look here on your periodic table, group 1 elements all have one valence electron. Okay, so it depends on the grouping. So group 2 elements have 2 valence electrons. Ignore the transition metals for now. It's way more complicated. We're not going to focus on that. If you look over here, so group 13 or 3A, 3 valence electrons. Group 14 or 4A has 4 valence electrons. Group 15 or 5A, 5 valence electrons. Group 16 or 6A, 6 valence electrons. Group 17, 7 valence. And then finally, group 18, these are the noble gases, 8 valence electrons. And so in order to predict what type of ionic bond and ionic compound arise from transfers of electrons, you need to know about this concept called the octet rule. And so the octet rule states that the octet rule says that an atom is the most stable when it has 8 electrons in its valence shell. And so if you look at the periodic table, the elements that are already stable are the ones that are in the 18th group or 8A group. All of these have 8 valence electrons. They have a full valence shell. There's no chemistry that happens with these elements. Every other element tries to either obtain electrons or lose electrons to have the electron configuration that these elements have in the 18th group, the noble gases. So the nonmetals tend to be highly electronegative, and these will attract electrons to have 8 electrons in its valence shell. And the metals, which tend to be low in electronegativity, will tend to give up electrons to have 8 electrons in its valence shell. So example number 1, we're going to take 2 elements and react them and create an ionic compound. Sodium and chlorine. And so what you have to do is locate both of these on the periodic table. You find that sodium is in group 1, chlorine is in group 17. And so the first step in figuring out the ionic compound and the type of ionic bond, you go here, you write down the element symbol, you represent each valence electron as a dot. So sodium was in group 1, that's going to have 1 dot. Chlorine is in group 17, it's going to have 7 dots. And chlorine has higher electronegativity compared to sodium. So it's going to be able to pull off this electron. And so this electron is going to be transferred to chlorine because chlorine is can attract electrons way better than sodium. Sodium has low electronegativity. And also, if you think about ionization energy, It has very low ionization energy, meaning that it's going to take little energy to pull off this electron. So chlorine is going to pull off that electron. And now chlorine now has 8 electrons in its valence shell. And sodium had 11 total electrons, but 1 was valence, and it gave up that 1 valence, and now it has the electron configuration of that of neon, which is more stable. But if neon gives up 1 negative charge, that means it's going to have 1 more proton now than electron. And so it's going to have a positive charge. And likewise, chlorine, which was neutral at 7 valence electrons, now has 1 more negative charge, and it's going to be negative 1 charge. And so positive and negative attract. And this is what the dot structure of this compound will look like. All right, example number 2, magnesium and fluorine. And so you go through the same procedure. You rotate two valence electrons. And fluorine, which is group 17 here, has 7 valence electrons. You put down 2 dots as a 2 valence electron, and you put down 7 dots around fluorine. And then fluorine, I mentioned, is the most electronegative. So it's going to be more electronegative. So this fluorine, pick up 1 magnesium, but 1 this has on the shell, so this can be negatively charged because, and then there's another because you can mix a whole bunch of fluorine together. And this other fluorine, of sodium, which is not stable, but it wants to be this is one more electron, and it had gave up 2 electrons, and so it'll have more protons than electrons because it gave up more electrons because it only had 10 electrons now because it had a total of 12 before, and now it has a positive 2 charge. Okay, so then positive and negative will attract. So you have 2 negative charge, 2 positive charge, and this will be this dot structure. And here's the joke. You can't see because of here, but the name's bond, ionic bond. It says taken, not shared.